we're really limited by the lack of design for additive know-how broadly within companies. I think we have a lot of corporations that have 3D printing departments, but until additive is sort of a part of how engineering is done, I think that's a major limitation. 3D printing companies are having to do the heavy lift of doing a lot of application development. That's limited by how much our customers allow us in to innovate with them. And I mean, obviously, we have a limited property set compared to I mean, the way stuff gets made, there's like thousands of different processes, and there are different ways that 3D printing can replace or offset or change. And the same, we have a limited set in terms of materials also. So you definitely need the materials to be up to snuff, and you need the speeds to be up to snuff. But fundamentally, you need to have that insight on the ground floor on how to apply the set of Legos that we have to solve a problem. I usually look for what is critical for performance. So for example, many times people will show a diagram that's made for injection molding with kind of a really low tolerance on dimensions, but they don't actually need necessarily that kind of tolerance. And so really knowing what features really require the dimensions and the dimension tolerance that they're talking about. Because usually with 3D printing, we can deliver that level of tolerance in specific locations, or, I mean, just like injection molding can, right? So injection molding has weaknesses also. It's just that people know how to design around it. And so really understanding how the part is used is critical, as well as, you know, sometimes there'll be a shape that's drawn, and it's drawn in such a way that it'd be easy for injection molding, where 3D printing, you know, you can avoid a whole lot of, you know, overhangs and stuff like that if you just changed how it pivoted. But you need the user to know, look, it has to fit here and here, you know, and then you can design for it.